Hello and welcome to my channel, Rhino here. Today we've got the final for now installment of the Pseudoscience Uprising series. If you're new, feel free to start with part 1, and I say final for now because of their weird upload schedule. They released one a week for 6 weeks, and now they're waiting until late fall for some unknown reason before releasing the actual final episode. Weird. Anywho, let's go!
Mutation. It is the key to our evolution. It has enabled us to evolve from a single-celled organism into the dominant species on the planet.
The advent of the nuclear age may have accelerated the mutation process. Individuals with extraordinary abilities may already be among us.
Yep. You can believe your eyes, you saw that right. We've gone from responding to strong scientific minds like Stephen Hawking to responding to Hollywood movies that no one would ever point to as being representative of the science of evolution. Well done, Guyrilla Fox.
Mutation is a critical ingredient in the recipe for evolution. Mutation generates variation, differences between individuals. Mutation generates variation.
Mutation, key to
Human evolution. Mutation, key to evolution.
What's fact and what's fiction here? Are mutations really the key to our evolution?
Basically, yes. I mean, reproduction kinda comes first, but if everything reproduced perfectly from the get-go with no mutations, then evolution wouldn't happen, so mutations are a pretty big driving force for evolution.
Think about it. In real life, significant genetic mutations don't create superpowers. They create super challenges.
Yeah, they often do. And nobody has ever seriously claimed that mutations give us superpowers. If they did, then you'd be bringing them up instead of the X-Men franchise. Is it still a straw man if the thing that you're attempting to debunk is purely a work of fiction and has never pretended to be otherwise?
Sometimes those mutations are even life-threatening.
Yep, they sure can be.
That's the reality. And yet we're told that random mutations with guidance from natural selection invented and genetically engineered every feature of every living organism.
Yes. Did you not notice the part of that where you said that these random mutations are guided by natural selection? That's kind of the key part of determining which mutations actually survive. Most mutations are neutral and we don't even notice them, but of the noticeable ones, most are detrimental and will do more harm than good, which is where natural selection kicks in. From a purely evolutionary standpoint, a mutation is harmful if it does something to hurt the organism's chances of reproducing. It is beneficial if it increases the chances of reproducing. So the detrimental mutations are gradually weeded out, while the beneficial ones gradually increase in number.
Changes to life's instructions happen more or less at random.
Mutation generates variation.
My god, I think this one might be the worst offender for their glitchy effects. Stop it. You're not making it edgy and appealing for the young folks, you just look like you're trying too hard. Or maybe you watched one video Copilot tutorial and decided that now you're an expert editor.
Let's go ahead and take a look at what we're going to be creating.
Or maybe these lame effects have been wearing on my nerves over the last 5 episodes, and this is just the one that finally wore through them.
Evolutionary biologists claim that random mutations accumulating over time ultimately produce life's features. If this is the case, zillions of chance mutations over the history of life led to the invention of flight and sight, immune systems, and reproductive systems.
Your personal incredulity notwithstanding, yes, that's exactly it. I don't know how much a zillion is, but I'm sure the number of mutations is in a range that is so large as to be completely meaningless to our monkey brains. And keep this in mind once again when you inevitably try to point out how improbable all of this is. How many trillions upon trillions, and maybe even zillions upon zillions of cells have existed over the course of the last 4 billion years? Given all that time and that huge number of cells, a certain number of beneficial mutations are inevitable. Add natural selection into the mix, and these inevitable beneficial mutations accumulate to create the amazing complexity of life that we see today. To think that that much genetic material could be around on the Earth and not have beneficial mutations is inconceivable.
Inconceivable!
even conscious beings with the capacity to love, reason, create art, and distinguish right from wrong.
Yep, even all that.
However, now, we no longer have to rely on speculative claims.
So you're giving up intelligent design then? Because last I checked, it was pure speculation. If there were more to it than speculation, then you would expect to see it pop up in publications more often, and you'd expect proponents of it to be able to give supporting evidence for it instead of relying entirely on the poking of holes in other theories.
Through experiments, we can actually observe mutations and see what they're doing to guide evolution. Biochemist Michael Behe has spent much of his life researching and studying mutations.
He's also spent a good chunk of his life being laughed out of court for ignoring piles of evidence as they are literally placed in front of him. Okay, he wasn't laughed at in the court itself, but it is pretty laughable that he could claim that we have no idea how the immune system evolved, even when presented with a big stack of literature explaining exactly how the immune system probably evolved. Oh yeah, and Michael Behe is another one of those excellent examples of scientists who are perfectly able to publish in secular journals when they do good work, but stay away from intelligent design when publishing in these secular journals.
Okay. In the past 50 years or so, methods have been developed to track mutations, changes in DNA at the very molecular level. Now we can watch evolution in real time.
Yep. And quite frankly, it's amazing how much we've seen in just 50 short years, considering the scale of time that it has taken for evolution to progress from these simple single-celled organisms that would have come first to what we see today.
Since 1988, biologist Richard Lenski has been conducting one of the greatest evolutionary experiments ever done.
He started a culture of bacteria called E. coli growing in his lab. And since they reproduce so quickly, now they're up past 60,000 generations. And that's like 1.5 million years of human lifetimes.
Yes, E. coli reproduce quickly, and this makes them well suited to this kind of experimentation. Notably, in Lenski's experiment, he had 12 genetic lines of E. coli in an environment where glucose would be plentiful for a certain period of time, followed by a restriction of the glucose supply. All 12 of his lines have mutated to reproduce about 80% faster, and different lines of bacteria accomplish this in slightly different ways, demonstrating convergent evolution. Interestingly enough, one of the lines of bacteria developed the ability to metabolize citrate. This potentially qualifies it as a new species, as E. coli's inability to metabolize citrate is one of its defining characteristics and is actually one of the ways we test for E. coli. They also determined by examining frozen specimens from previous generations that it was not one single lucky mutation that caused them to gain this ability, but it was an accumulation of other mutations that eventually gave them this ability. So now let's see how you misrepresent this experiment to claim that it's not evolution.
So we are talking about numbers that are big enough to see some serious changes, if serious changes could come about.
Not only that, but we're actually talking about seeing some serious changes, because serious changes can and do come about.
In his work, he's seen a lot of beneficial mutations come along. But turns out that the great majority of the mutations were in pre-existing genes, and they either broke or degraded the genes.
Okay, and why is that a problem? He found a bunch of beneficial mutations, and we already know that the majority of mutations are neutral, and we already know that there are more detrimental than beneficial ones, and we know that selection pressure takes care of this. So why is it a problem when his experiment finds that the ratio of beneficial to detrimental mutations is pretty much what we would expect? The fact of the matter is that he observed a series of mutations that probably qualify that strain of E. coli as a new species. It was a beneficial development that would actually have been detrimental in an environment with abundant glucose, but in an environment which gets its supply of glucose limited, the ability to use citrate for metabolism helps them with survival. Are you going to mention this probable speciation event that we have directly observed in lab conditions, or are you just going to dance around it with the claim that some of the mutations were detrimental?
So the bacteria were evolving, improving more by devolution than by evolution.
Evolution has no direction. If the loss of genetic material or the loss of a function is beneficial, and so an organism loses that genetic material or function, that is evolution. I do not know whether or not the ability to metabolize citrate was accompanied by an increase or a decrease in genetic information, and quite frankly, I don't care, because it doesn't matter. Sometimes the amount of genetic material goes up, sometimes it goes down, sometimes it stays the same. It doesn't matter. What matters are the effects of the expression of the genetic material. Sometimes good things can happen with a decrease, and sometimes bad things can happen with an increase.
It's difficult to understand how breaking a gene can be beneficial or helpful.
If the gene codes for something that is not helpful, then not wasting resources on that gene and what it codes for is helpful. We have broken genes for the production of vitamin C. We need to get vitamin C from our diet because of these broken genes. But likely they were allowed to break because our diet changed to include foods that are rich in vitamin C, so wasting our resources making a vitamin that we now got through our diet was detrimental, so our ancestors with the broken version of this gene had a slight advantage. The question with this one is, why would an intelligent designer give us a broken copy of a gene which is fully functional in all other vertebrates with very few exceptions?
Think of it this way.
Suppose you had a car, and the most important thing to your survival right now was the gas mileage. What could you do to improve the gas mileage of your car quickly? One thing you could do is rip out the back seat and throw it away. Back seats are helpful, but if your life depended on you getting better gas mileage right now, that would be a beneficial improvement.
Good. I'm glad you understand. This analogy actually works pretty well at the moment, though I'm sure it won't take you long to light it on fire and throw it into the nearest gas-filled dumpster.
The problem with that, for Darwin's theory, is that ripping the back seat out of a car doesn't tell you how you make a back seat. Darwin's theory needs to show that organisms can improve by building things.
And there it goes. See, the problem here, and with most creationist analogies, is that there is no reproduction with cars. If cars reproduced and had genetic material like what we have, then the same mechanisms that break the part of the genetic material for making the back seat could also be responsible for building that part of the genetic material to begin with. We know that insertion mutations exist. We also know that deletion and substitution mutations exist. So one type of mutation takes stuff away, another puts stuff in, and another just swaps stuff out. The one that puts stuff in is responsible for the new stuff. The one that takes stuff away is responsible for the stuff that goes away. It's really not that difficult, though it does get more complicated when you realize that adding extra material can break a gene just as much as taking material away, and likewise taking stuff away from a broken section of genetic material could potentially fix it or give it a new function.
And that's what has been missing in this terrific experiment.
Was it missing, though? In the article that you guys were showing, I didn't see anything stating that the development of the ability to metabolize citrate was the result of a degradation of genetic material, just that it was the result of mutations. In fact, in previous videos, when stuff like this has come up, it's always the creationists claiming that mutations can only cause things to go away or get worse, while the scientists who are actually running the experiment make note of how many insertions, deletions, and substitutions there were. But they don't generally make a fuss about whether the insertions cause a new function or not. In fact, in the dark fly experiment that I reference in my video response to Kyle Butt, side note, teehee Butt, they list insertions and deletions as one category, indel mutations, and they observe about 4,000 of them. To me, this suggests that the amount of genetic material is fairly irrelevant. What matters is what the genetic material actually does.
This famous E. coli experiment shows that trillions of random mutations are not capable of building anything new.
No, not trillions. About 45 in that specific case. And why are you leaving out the new feature of metabolizing citrate? Are you going to address that at all? It's in the very article that you yourselves showed. But as we learned in previous episodes, you guys don't appear to be very fond of reading past the headlines.
By the numbers, this E. coli experiment is giant, but it's dwarfed by the size of a natural experiment involving humans infected with malaria.
Every year, about 1 billion or so people contract malaria. So that's 1 billion times 1 trillion cells that are made each year on the planet.
In recent decades, scientists have exhaustively studied malaria. They've seen how it evolved resistance to several of the drugs used to treat it. But what is more interesting is what scientists haven't seen.
Well, whatever you're about to say, I'm just going to undermine it here by pointing out that you just said that it evolved resistance to our treatments. Kind of a neat trick if evolution isn't a thing, wouldn't you say?
There were no new molecular machines, no new genes, and yet it had so many chances, evolutionary theory would have predicted that you'd get something really pretty impressive out of that, but it wasn't seen.
No, there's nothing in evolutionary theory that says an organism must evolve new features or structures or whatever you're saying we should have expected given a certain amount of time. If there were no selection pressures to develop new structures wouldn't develop. As you said, 1 billion people contract malaria annually. Well, it's really 300 to 600 million, but let's just roll with your inflated number. That sounds like a pretty successful bug. Perhaps it is so successful that the selection pressure just isn't there to do anything other than evolve resistance to our treatments. This is why controlled experiments like the E. coli one are so valuable. They provide a selection pressure and isolate as many variables as possible so they can be sure of what is happening in their experiments. With a wild population, there is no control on selection pressures. There is no assurance that all strains are exposed to the same selection pressures. There's nothing to ensure that the selection pressures remain consistent over time. In short, observing wild malaria cannot be equated with a controlled experiment.
And it's not just malaria. It's not just E. coli. The pattern is widespread. For Behe, this raises a serious red flag for evolutionary theory.
The discovery that many beneficial mutations are actually destructive or degradatory mutations puts a huge monkey wrench into Darwinian theory.
No, it really doesn't. It does explain why so much of our genetic material is broken, though. And no, I'm not going here for the most of our DNA is junk DNA argument. I'm talking about very specific genes that are in our genetic code and don't do what they should do, like the vitamin C gene, or the 11 broken copies of the nanog gene that we have scattered throughout our genome. The working nanog gene helps preserve embryonic stem cells while they are still needed. There's also the broken CMAH gene, which helps build a sugar molecule called sialic acid on the surfaces of cells. It has been hypothesized that the loss of function of the CMAH gene is responsible for humans becoming such good long-distance runners, as mice that were mutated with the broken human version of the CMAH gene were able to run 12% faster and 20% longer than their non-mutated counterparts. So we all have these genes just lying around and not doing much of anything except taking up resources. And we know what these genes are supposed to do, but they don't do them because they're broken. This lines up perfectly with evolution, but it flies in the face of intelligent design.
Not only can't Darwin's mechanism of random mutation and natural selection build complex systems, it has a strong tendency to degrade them.
No, the mutations are what have a strong tendency to degrade them. The natural selection is what stops them from degrading, as the more degraded ones tend to be selected against. Though you do appear to be talking purely about the amount of genetic material, but more genetic material does not automatically equal better.
This means beneficial mutations, what we have been taught are the building blocks of evolution, show no observable capacity to build or invent.
I mean, they do. Just because you ignore the examples of it doesn't mean it doesn't happen.
We see that overwhelmingly the good mutations come about by breaking old genes.
Notice his careful choice of wording there. Overwhelmingly. But not exclusively, and therein lies the key. If just an occasional non-damaging mutation turns out to be helpful, then that means there is something there for natural selection to work on, and over millions of years they can add up. Remember at the beginning where you pointed out that evolution requires zillions of mutations over billions of years, as if that somehow hurts evolution's case? With the beneficial mutations overwhelmingly damaging genetic material, that means that there's still a bunch left that build it up, or repair it, or whatever.
So you're not making something new, you're throwing out something you already had.
Yeah, sometimes, and that's not a problem.
We see it in bacteria, we see it in mammals, we see it in birds, we see it everywhere that's been looked at so far.
And it's expected, but as your own language in this matter suggests, damaging mutations are not the only kind of mutations that can be beneficial, so it's a moot point.
This scientific evidence completely conflicts with evolutionary theory, and that is why the public never hears about it.
Yeah, the public does hear about beneficial mutations. What they don't hear about are the genetic mechanisms behind those mutations, because the public usually finds such details to be boring. But the information is out there for the people who want to find it.
Only a few brave scientists have been willing to speak out, like Lynn Margulis.
Valadares. Wait, what?
I was taught over and over that the accumulation of random mutations led to evolutionary change, led to new species. I believed it until I looked for evidence.
I was unable to find the source for this quote, so I will just assume for argument's sake that you are not misquoting it. Lynn Margulis, wife of Carl Sagan from 1957 to 1965, was one of the pioneers of endosymbiosis, which is the idea that mitochondria and chloroplasts originated as symbiotic bacteria. She was critical of the idea that mutations alone were the driving force of evolution, so I'm about 99% sure that if I were to find this quote in context, she would be discussing mutations as opposed to another mechanism, such as the role of symbiotic relationships. And if you read through her wiki page, it seems that she was a bit of a contrarian who was fond of making bold statements just to cause a reaction. She is a very important figure to evolutionary biology, so to list her as having spoken out against evolution is rather disingenuous. But I expected nothing less from you guys at this point.
So if mutations aren't the building blocks of evolution, what can explain the invention of new things like the cell, or the eye, or flight? In birds, we find all kinds of amazing interdependent features that appear orchestrated for flight. We know from experience how difficult it is to get a flying machine and what it takes to build one.
Yeah, but we also know that jumping is possible. And sometimes jumping is a good way to get away from a predator. And if you have feathers that were already adapted for warmth, then a flap of the arms while jumping might cause you to jump just a little bit higher. And the ones that can jump higher have a survival advantage, and so on and so forth. And that's one of the ground-up hypotheses for the evolution of flight.
We observe things like purpose and function coming from intelligent sources, not from blind material processes.
True, but we also observe things like genes to grow teeth in chickens. They don't normally grow teeth, but they have the genes that will allow them to, just broken. What part of that suggests design?
So when we see design, engineering, and artistry throughout nature,
we don't. We see what superficially appears to be designed, but a closer look reveals that it is most definitely not.
Shouldn't we be looking for a designer?
Maybe if we actually saw evidence of design, but when you have to blatantly misrepresent people's opinions on evolution and omit facts about experiments that you're talking about in order to make it look like there might be a slight chance that you're right, then you're probably not right. That's it for this one. All they have left is them going into their creepy culty chant thing. So today's comment of the day comes to us from Aro, who says, "And you questioning people like James Tour who doing science every day in lab and have much more experience than people who just imagine what is possible and what is not." I'm going to forgive the lack of punctuation and awkward wording there with the assumption that English is not this person's first language, and I'll just address what I think they are trying to say. So yes, I do question people like James Tour who do real science. I also question people like Martin Hanchik, who is one of the scientists whose research was being questioned in the video that this comment was posted on. Questioning the validity of someone's work is one of the key components of the modern scientific process. That's the whole point of peer review. So no, I am not as qualified as James Tour to talk about synthetic organic chemistry. But when Dr. Tour comes out with unsubstantiated opinions about an area of scientific research that we already know contains a lot of unknowns, I look to the opinions of others in the field, and they almost universally agree that Dr. Tour is wrong. He is an intelligent man, but the only argument of his that I've seen for intelligent design is that we don't know how certain aspects of abiogenesis happened, therefore it must be the result of intelligent design. That's all it breaks down into. Yes, he uses big words, a lot of which I have to look up in order to just get a basic understanding of what they mean, but it all comes down to we don't know, therefore God. This is a very basic logical fallacy. No matter how educated someone may be or what scientific achievements they have under their belt, fallacious reasoning is still fallacious reasoning. Links to social media and ways to support the channel are in the description, as well as my P.O. Box address. And I would also just like to mention that now my patrons get my videos a day early, so if that's something that interests you, consider becoming a patron. See you next time!